Good morning, Cyprus. Hope you're all okay and managing all right with the home learning again. Fortunately, it's not for so long this time. So here is today's maths lesson. I've tried to keep it the same as how we do it mostly at school as much as we can. So to start off with, I've popped a flashback 4 on this slide. So you could maybe pause the video and have a go at completing this flashback 4 into your books that you've taken home from school. And then once you've finished it, you can unpause it because the next slide has got all the answers on it. So try not to have a peek before you've had a go and give yourself 5-10 minutes to see how many you can get done. All right, so pause the video and I'll see you in a minute. Okay, so here are the answers. I'm not going to go through all of them, apart from number 1, where hopefully you spotted that because you're taking away 2 mixed numbers, that you really needed to pop them into a improper fraction first. And you can see that I've over here done it where I have put my 3 2/5 into 17/5. And then I needed to pop that into tenths before I could do my takeaway calculation. So you would get the answer correct if you had an answer of either 13 tenths or 1 and 3 tenths. Now the other ones are all pretty self-explanatory. The challenge, you had to figure out, first of all, what fraction of the 255 was the same as 2/3, which was 170, to find out how many red pens there were. And then to find out how many blue pens, you had to find out 1/5 of 255, which was 51. Add them together, and then whatever was left behind tells you how many yellow pens that you needed, which was 29 yellow pens. Now, that's the number of pens that you would have, but to write that as a fraction, you just had to put that over the 255. They can't simplify because 29 is a prime number and it doesn't divide into 255. Okay, so here we are with our Discover for today. Now, the challenge that we've got for the lessons today is that we're actually looking at coordinates still with shape, but there's no numbers on our axes, as you can see from the picture. Now, let me just give you 30 seconds, first of all, to have a little look at what they're saying, the 2 children, what they're trying to do in the work today. Okay, got rid of my scribble now. So hopefully you've had a little read of what it says. And you can see that on shape P here, you can see point A, which is at 1, 2, and B is at 4, 2. Now, the first question that we've got to answer is what are the coordinates for C and for D on shape P? Now, this is really hard because I know if we're in the classroom, you'd be saying, this is large, there's no numbers on our axes. How am I going to figure it out? Well, first of all, I want you to think, what shape is P? Shape P is a square, isn't it? So if we're looking at a square, we know that all the sides are the same length. So because we've got the 2 coordinates of A and B, we can use that to help us, because from A to B, if I'm going along the x-axis, I can see that A is at 1 along and B is at 4 along. So how many sort of squares would there be, or numbers would there be in between those 2 points? There would be 3, wouldn't there? So that means each side of this square is 3 centimetres or 3 points along. So if we start off by having a little think together about C, this is how I would calculate it, like this. So I think, right, if I'm doing C, oh dear, my board, wait a minute, sorry, let me just turn this. I think my pen board is upside down. That's what's giving me some problems. I'm sorry for the interruption. Let me just get rid of what's on there. I haven't used this for a long time, so I'm getting it all in the middle. Right, let's try that again. So if I first of all start to think about C, that's better, it's working now. Now I can see that B is 4 along and 2 up. Can you see that over here? So for B is 4 along and 2 up. So I know that C, because it's straight above there, that must also be 4 along. Okay, now I've just worked out that there are 3 points between each coordinate on this square, because squares have the same side. So if B is at 2 up, then C has got to be 3 more than that. So that makes it 4, 5. Okay, and then for D, I can do exactly the same, but I'm going to use A to help me now. Now A is 1 along, so that means that D must be 1 along, and it's 2 up. So again, the sides are 3 points higher. So 3 more than 2 is 5. And I can see that that's correct because C and D are the same level. And so they both have the height of 5. Okay, hopefully that makes sense. You've got some questions like this in your book today. Now for the point Q down here, we can use a very similar method. Now we can see that Q has been translated, it's been moved away from P. Now you can have a look. If I were to look at, I'm going to focus on, because I've been given E and A. I can see from A, this one was 1 along. Now E is 3 along. So this must have been translated 2 to the right, and it's gone from 2 to -5. So it's gone 2 right, and it's gone 7 down, because I can see that I've gone 2 to get to the x-axis and then 5 more down. That might help me when I think about this, or I can use my knowledge of a square to help me. If I were to look at H, I could think, well, H is going to be the same number along as E. So H is going to be 3 along. Now I can see on here that this looks very similar, because my top coordinates for this one, when I looked at C and when I looked at D, they were 5 up. Now on here, E, I can see is -5 down. So this must have been the same distance away from that x-axis as P is. So that means that H must be 3 minus 2, because I can see that I am the same distance away from that axis. And I could do the same as I've done for P on Q. If you'd like to, pause the video and have a go, see if you can figure out the coordinates for the rest of Q. Okay, so we've answered that question. Now, here is our turn, one that we would do together on the board. This is very similar. So Eden and Noah have been given some axes showing 2 squares which are identical. That's the important bit of information here. Now, P has got some missing, so we're looking now to find the coordinates B and C for P. So can you think about what we just did in the previous slide and have a go? Pause the video, have a go, write your coordinates down, and then I'll pop up the answers. Okay, so hopefully you've had a turn now. Here are the answers. Point B should be 4, 1, because we can see that we're now, again, we've still got 3 between them. So it's gone 4 across and 1 up. And point C should be 4 along and 4 up. Okay, hope that you got that right. Oh, sorry, apologies, I went forward too quickly. Now for Q, again, you could have another turn and think about how it's changed P to Q. If you're in Mr. Hall's group, I would expect you to really have a go at this for maths normally. If you're with him, then have a go at seeing if you can plot those coordinates for Q on there, thinking about the translation from P, because that will give you some guidance to help you. Okay, so now sometimes with these coordinates, we look at triangles. It's not always squares. Now this is an isosceles triangle. Excuse me. So can you remember, an isosceles triangle is one where it has 2 lengths which are the same. So that would be this one and this one. It's like a Christmas tree, isn't it? And so that makes it an isosceles triangle. It's got 2 angles the same, 2 lengths which are the same. Now this time we're trying to find the coordinates for point C. Now this thinks, this is a bit harder because again we have no numbers on our axis and we have only got the coordinates A and B to go from. Now, because the lengths of those sides where I put those little lines on are the same, that means if I was to draw, now this won't be very straight because I'm doing it freehand, but if I were to draw a line down here to there, that would fall halfway between A and C. Now, if I look at the along coordinates, the one which will go across, so A is 1 along and B is 2 along. So this means that this is 2. So there's 1 difference between them. So that means I must know that C is 3 along because there's going to be another 1 more from here. Now I can use A to help me with how many it's gone up because it's on the same level. So this one would be at 3, 2. Okay. All right. Now there's our answer to show us that we're right. Now I've popped up here. I've tried not to go on too long so you can crack on and have a go. These are your pages which I will have sent to you through Class Dojo. I'll put them on your portfolio. I know some of you aren't being able to get onto your portfolio, so I will also put them on the class story. Now, some of these are fine. I think you're going to find question number 1, question 2, they're very similar to what we've just done on the board together. And number 3, again, I think you can work through. Number 4 is a little bit more of a challenge. Have a go. If you can't print them off, don't worry, just look at the screen and then you can write the answers into your yellow books. And then if you manage to take a photo and then send it on to me and let me know. I'll try a bit later on. What I'll do is I'll give you a bit of time to do some work and then I'll send the answers, put them up so you can mark them and have a look, see how you've got on. So any problems, I'll be on Dojo until lunchtime, so you can always send me a message if you get stuck or you need any help. Have a lovely day and a nice weekend, and I will send another video for the work on Monday. All right then, take care. Oh, one more thing on the next slide, which I will leave it on now, is the challenge. So if you find this really easy and you whiz through, you can pause the video on this challenge and have a go at that to keep your brain busy. All right, good luck everyone, and I'll see you soon. Bye.